So in this unit, we're going to revisit factoring to make sure we're good to go on that before we start on our next topic. So first, we're going to make sure you remember how to factor by GCF and grouping. So GCF, also known as the greatest common factor, that's what GCF stands for, means that we're looking for the biggest term that will divide all the terms in an expression. And when you're factoring, you always want to look to see if there's a GCF first. So let's do some examples with factoring by GCF. Example 1 says factor by GCF. Now, some people can just look at the terms and decide what the GCF is. Some people need to list them out. Now, if you think about 6 and 9, we're going to talk about the numbers first. 6 and 9 are both divisible by 3. That's the only thing that divides them, and obviously it's got to be the greatest one. But some people look at these variables and they don't understand what I mean by GCF. So I'm going to write out the terms the long way. Well, x squared is the same thing as x and x times x, and then we have x times y. So, like I was saying before, for 6 and 9, the GCF of those numbers is 3. And then you want to take a look at how many of each variable do they share. Well, both of these variables have one x in them, so we can pull that x out. So that's the GCF. We have an x left in the first term and a y left in the second term. Now, even though there's a y in the second term, because there's not a y in the first one, we can't pull that out for the GCF. So we have 3x. We pulled out 3x. 6 divided by 3 gives us 2. X squared divided by x gives us x. See, we got an x left because we pulled that x out. Plus 9 divided by 3 is 3. We took this x away, and then we have y. And the way you can check these is simply by using the distributive property. 3x times 2x is 6x squared, which we're good to go on that one. And 3x times 3y is 9xy. So we get back our beginning. So here is our factored binomial. Okay, let's look at B. B is a little bit more complicated. Now, before we even think about the numbers, I'm going to go ahead and write out all the terms with our variables listed out. So we have 15. X squared is x times x. Y to the fourth is 1, 2, 3, 4 y's, and then we have a z. Plus 3. X, y, z all have an exponent of 1, so that's just going to be x, y, z. Then minus 12. X squared is x times x. Then we have y and z. Okay, so we've got them listed out, all of our factors. So let's look at our numbers. The largest number that's going to divide 15, 3, and 12 is 3. So we're going to pull 3 out. 3 is going to be part of our GCF. So then let's take a look at the first variable. The number of x's that each term has in common is just 1x. So I'm going to pull an x out, and I'm going to take it out of our term. So we're taking that one out, this one out, and this one out. Now let's take a look at our y's. Each term has one y in common, so pull out a y. And then take a look at our z's. We have 1z, 1z, and 1z. So each term has one z, so I'm going to pull a z out and cross them out of our terms. So then we got to figure out what we have left. 15 divided by 3 gives us 5. Then we have an x left. And then we have 3 y's left, which is y cubed. Plus 3 divided by 3 is 1. And we don't have any variables left. But you've got to put this 1 here to hold this spot. If you don't put the 1 there, whenever you go to redistribute, you're not going to get back the same thing. And then 12 divided by 3 is 4, so we have minus 4. And we have just an x left. So here's our factored polynomial. You can check this always by redistributing. Okay, so let's look at factoring by grouping. Factoring by grouping, all it is strategically factoring by GCF. We've got 4 terms, and what we're doing is we're choosing 2 terms to go together and another set of 2 terms to go together, and we're going to factor out a GCF in both of the 2 parentheses. We want what's left in the parentheses to be the same thing. So let's take a look at example 2a. So you always want to group together two terms and two terms. Now most people just go ahead and try. We're going to group together these terms and these terms. But you've got to be really careful with this sign right here, because when we start getting to ones like B, we might run into some issues and have to change some signs. But if you put these parentheses around this, we've got plus all of this, and if you distribute out a positive 1, you'll get the same numbers back. So we're fine in this case. So let's look at the first parentheses. We have a cubed and 4a squared. The GCF for these two is a squared. And what we have left, a cubed divided by a squared is a, and negative 4a squared divided by a squared is negative 4. Okay, so we're good to go on that one. Now, for the second term, whenever we factor out a GCF, we want to have this left. So the number GCF for them, they're both divisible by 3, and actually there's no letter that they have in common. So 3a divided by 3 is just a, and 12 divided by 3 is 4. So we set out to do what we needed to do. We wanted these two to be the same, and they are. So now, here's how you're going to write your terms. A squared plus 3 is a term. And then the other term is just a minus 4. And we have factored that by grouping. Now let's look at B. On B, we're going to run into some issues with some signs, and I'm going to teach you how to handle that. So let's go ahead and try to group together the first two terms and the second two terms. Now, be careful when you're grouping together here, because notice we've got this minus sign. If we distribute out this minus sign, we want to get back the original. But here, our original was minus 2x minus 10. But if we distribute out the negative to the 2x, we'll get back negative 2x, which is fine. We distribute this negative out to the negative 10, we would get positive 10, which is not what we have here. Don't know what that stray mark is, sorry. So what we have to do here is we have to change this sign right here from a minus to a plus. Now when we distribute out that negative, we'll get back the negative 10, which is what we need. Okay, so now we can carry on like we've been doing. We're going to factor a GCF out of both of these terms. The GCF out of the first term, there's no number, but they share x squared. X cubed divided by x squared is x, and then 5x squared divided by divided by x squared is just 5. So we have our minus sign from here. Now, whatever we factor out, we want to get x plus 5. So they have a GCF of 2. 2x divided by 2 is x, and 10 divided by x is 5. And see, if we hadn't changed that sign, we wouldn't have gotten this. So now we have what we needed. We want those two to be the same. Now we can write our terms. Our two terms are x squared minus 2, then x plus 5. Let's do another example of factoring by grouping. Okay, C. So this time, we're going to go ahead and try to group the first two and the second two together and see what happens. Going to group together these two, and then look, we got that same issue with that sign. If we group together these second two, we've got to change the sign of this number, because when we redistribute out this negative sign, we'll get back a positive 9, which is the original problem. Okay, so let's see if this works. We're going to pull out a GCF. Let's see, in the first two terms, they're both divisible by 2, and they're both divisible by z. So 8yz divided by 2z is 4y, and then negative 6z divided by 2z is negative 3. Okay. Then, for this one, we've still got our minus sign from here. They're both divisible by 3, so we pull out a 3. And then that's it. So we have 4y minus 3. And we got exactly what we needed. We wanted these two to be the same. So our goal is accomplished. So let's write our two terms. We've got 2z minus 3. And then we have 4y minus 3. And that is our factored polynomial.